I'm asked to draw a triangle ABC where the length of BC is 4.5 centimeters. The measure of the angle ABC is 90 degrees, so it's a right-angled triangle, and the measure of the angle BAC is 50 degrees. So first, I'll draw a freehand diagram, and I'll put in the information that is given. I'll make this look roughly like a right angle. So the right angle is the angle ABC, so that means that it's at B, the middle letter. So if that's the right angle, this will have to be B. I'll call this point A and this point here C. Now I'll put in the other information. The length of BC is 4.5 centimeters. And the measure of the angle BAC is 50 degrees. So now I'll follow this diagram to draw the diagram accurately. So first I'll make BC equal to 4.5 centimeters. I'll mark the point 0 on the ruler, and I'll mark the point 4.5 on the ruler, and I'll join them up. And that's B, and that's C, and the distance between them is 4.5 centimeters. Next, I'll make this angle here at B 90 degrees, and I'll use the internal angles of the polymath for that. So I'll just move the polymath along, put this edge along the line here, and I'll move that back along until B reaches one of the down edges, so this one here. So that's the right angle. Now the other bit of information I have is the angle at A is 50 degrees, but I don't know where A is. I have no length from B to A, so I can't make an angle of 50 degrees there. So I go back over to my diagram and I do a small bit of calculation. The three angles in a triangle always add up to 180 degrees. So if I'm ever given the size of two of the angles, it's as good as being given the size of the three, because I can just add the two I'm given and subtract from 180 degrees. In this particular case, it's very easy to do the calculation because 90 degrees are gone on the right angle. So that just leaves another 90 to be shared between these two angles. But this one has got 50, which leaves 40 for that one there. So that angle there would be 40 degrees. So I'll go back over here, and at the point C, I'll make an angle of 40 degrees, and I'll use the protractor part of the polymath, and I put the arrow just there at C and the line along the line for the 0 on the angle, and I'll go now 10, 20, 30, 40, and I'll put a dot up here. Might be gone off the frame, but you can believe me that it's up there, and I'll join C to that dot up there. Now I made this angle 40, so automatically this one here has to be 50 degrees. And this point here, where the perpendicular intersected the line for the angle 40, that's point A. So I'll just go back now and check with the written instructions if everything is the way it's meant to be. Well, it's a triangle ABC. BC is 4.5. The angle ABC is 90 degrees. And the angle BAC is 50 degrees. So everything is as was asked.